Okay, dokie. Let's go ahead. So, we are going to continue our very, very fun journey into more unit conversions today. We're going to be talking about a couple of things today. We'll be talking about, when we're dealing with squared or cubed units. We're going to talk about Sig Figs, of course. And we're going to talk about kind of special cases. We're going to use a couple of kind of special conversion factors that are kind of important enough that they have their own names. Conversion factors. Okay. Just to have it all up here so you guys can see what we're doing today. So, of course, as always, if there's anything that was not too clear last time, just throw it out now or whenever you feel like it, and we can go over that. Otherwise, we're going to go ahead and get started with more conversions here. I guess also we should talk about kind of... I don't know, let's throw a fun term out here. Multi-unit conversion. I don't know. We'll just say those are including complex units. We'll talk about those as well. I guess we're not going to necessarily do it in the order I've written here, but whatever, it's fine. This is all the stuff we're going to cover kind of today. And if we finish this, then we'll start talking about atoms, but I don't think we'll finish it. So, but that's okay. Let's talk about cubed units or square units. So, squared units often refer to something like area. Let's say centimeters squared, which is an area unit, right? You have this index card or whatever. It has, certain measurements by each side. We could find out its area. Its area would be in square centimeters. And so we're going to see that we could have similar units that would use a length measurement squared to also talk about areas. Good morning, Angela. So let's go ahead and do a problem here. So let's say I have 92.4 centimeters squared, and I want to find this in square meters. Just to refresh, kind of our knowledge, we remember that 1 centimeter is 10 to the negative 2 meters, right? Good morning. So don't forget, of course, our metric prefixes. Those are going to be with us basically the entire semester, so keep on working on memorizing those. So let's go ahead and do it. Let's see what we can do here. So if we take our measured quantity of 92.4 centimeters squared, if we just try and put in our plain old unit conversion ideas here, notice we would put centimeters on the denominator so that it would cancel out. And we're going to keep the 1 with centimeters and then the exponent component with the base unit of meters. If we do that, we get this lovely answer here. Meters per centimeter would be our unit, right? We're going to see, centimeters squared will cancel one of our centimeters out. So we're left with, actually this would be multiplied, wouldn't it? Shame on me. Meters times centimeters. What the heck is that? I mean, technically that is a unit, but that's never something that we would normally see, right? Nobody takes different units and multiplies them together in this sort of manner for two different lengths. So, not quite there yet. So, we're going to say, well, actually, if we take that number, that 9.24 times 10 to the negative 1 centimeters times meters. Let's go ahead and do this again. Let's put our centimeter thing on the bottom and our meter thing in the numerator. Aha, how about this time? Oh, I really should remember my exponents. Now let's look what happens. We're going to have centimeters cancel out, and we're going to have meters times meters, right? Which is going to give us square meters, right? So we've got meters here, multiplying those together gives meters squared, right? Doing the math. We would get something that has the appropriate units for us. So assuming we've plugged in our things in our calculator just fine, or we've just used our brains because this is just doing exponent thingies, we will have gotten our answer. Hooray! And so we can see that's how we would do it. Notice we had to use our conversion factor twice here for the squared unit. And notice if we were to just, put this all out at once, I'm just going to rewrite what we did here. We had 92.4 square centimeters, where we multiplied it by our first conversion factor, and then our second one, and we got our answer. Times 10 to the negative 3 square meters. Hooray. Notice that this thing, that part in the middle there that we had to use twice, that's the same thing as squaring our conversion factor. Mind blown, right? You can just square your conversion factor. And if we do that, I'm going to just have to go left here. That would be the same thing as writing it like this, right? If we were to square that conversion factor, we would see that there would be 10 to the minus 4 square meters for every 1 square centimeter. And so we can just use that as is directly. So we can say now, save a little bit of time and square our conversion factor to begin with. And now we can see right away that the centimeters squared will cancel out and we'll be left with meters squared. And so again, I've written this number like 5 times. We of course will still get the same thing. So when we're dealing with square units, you can either just use your conversion factor twice, though that can take a bit more time, or you can just square your conversion factor, which is the way I would recommend doing it. So just note that if you're going to square your conversion factor, everything in it has to be squared. So every component in that fraction needs to be squared. And guess what? The same is going to hold for cubic units too, where we would have to cube our conversion factors. So how about we write this in light blue? So when working with squared or cubed units, you may need to square or cube your conversion factor. Notice that I'm saying may here. I'm going to show you in just a second kind of why we have to indicate may. I'm going to just put as kind of a footnote here. When going, well, let's see, from or to a, let's just say from a square or cube unit to a non-squared or cubed unit, you don't mess with the conversion factor. And let's take a look at what that means. If we were to say, look at one common conversion factor for us, which is that 1 milliliter equals 1 centimeter cubed. For example, notice that this conversion factor already has the cube unit in it. And so we don't need to mess with it. It's already taking care of the cube aspect for us. We don't need to worry about it. However, if we wanted to go from cubic centimeters to, cubic millimeters or something, we would need to worry about that. Because we can't just say, oh, you know what, 1 centimeter is 10 I guess I shouldn't say this, but 10 millimeters. We cannot say that this is the case. This is a big no-no. That's not the same thing. So it's kind of just the lesson here is pay attention to what units are given in your conversion factors. So if we were dealing with cubic centimeters in either case here, we would say we don't touch that one because it already has the cubic unit in it. And then depending on what you're doing, you may need to mess with the second one if you're dealing with squared or cubic units. So just pay attention. That's the idea here. Let's go ahead and do this in context here. How about we take 8.24. Didn't I just use 0.24? Let's not use that. How about 0.37? Yeah, there we go. Centimeters cubed. Let's go to two things. Let's go to millimeters cubed. That'll be problem 1. And then for problem 2, let's go ahead and put that in milliliters. So we can see when we're going to need to deal with messing with our conversion factor. So let's go ahead and take a look at this. If we are going to convert centimeters cubed to millimeters cubed, well, luckily I've already given you a conversion factor, but let's go ahead and use our metric prefixes just for practice. So let's ignore that one that I had written there in black just above. If, last Wednesday or whatever, we were trying to do something like this, we would say, okay, first we need to go to the base unit, and then we'll go back to our other prefix unit. So let's just go ahead and do it that way, just so we're in the practice of doing that. Good morning, Em. And so we'll get that there. So if we do that, we know that 1 centimeter is 10 to the negative 2 meters. And we know that 1 millimeter is 10 to the negative 3 meters. So if we do this, remember, we're going to have 2 steps, so we're going to need 2 conversion factors here. Always make sure you cancel out the ones you don't want. and you're going to have to put the other one on the other side of the fraction. If we're now in meters, we're going to have to put meters on the bottom and the unit we want on top. Now remember, since we are dealing with cubic units, we are going to have to cube. Here, let me do the cubing part in a different color, just so we don't go crazy here. We're going to have to cube both of those components. Because if we look at our measured quantity, it is in cubic units, but our conversion factors are in singular units. That's when we have to cube our conversion factors. So that's what we had, that disparity there. So if we do that, sometimes it's just easier to cube the conversion factors before you do the math. Though, I mean, it's always up to you how you like to do that. If we cube our first conversion factor, that's what you should get. Remember that if you square or cube an exponent, you multiply it, right? If you're just, so it should be -6, right? The second conversion factor we have, if we cube that one, oops, yeah, no, that's right. That's what we're going to end up getting. What's up, Eddie? Which was some of that confusing, or just need a second to think about it? Oh, cool. Okay, awesome. Yep. So, if we now take a look at our units, now that we've cubed our conversion factors, what am I doing? Let's go back to black. Oh, now we can see. I'm going to just use blue because red and green don't really look good together. Aha! Centimeters cubed cancels. Meters cubed cancels. And we're left with millimeters cubed. Doing this math, we should end up with 8.37 times 10 to the third millimeters cubed. Hooray. Just remember that 10 to the -6 over 10 to the -9 is just 10 to the +3, right? If you are dividing exponent things, you would subtract them. So -6 minus -9 is +3. And so that's how that came there. Or again, of course, you just throw this on your calculator, no problem. You would get out the right answer. All right, how was that one? So what we had to do there was cube our conversion factors. And we would get it that way. The kind of the like beauty of this process is, it'll always work. If you can master this skill, honestly, you are going to have no problem doing the mathematical parts of this class. We're going to be using it pretty much every day in topics where we're going to be doing math. There's going to be a few that we don't really do math in, but if we're doing math, you can bet we're going to be using conversion factors and unit conversion. So I would very, very strongly recommend that if you have trouble with this, that you ask faster version for it. I mean, there are faster ways to do things like this. Symbols are arbitrary. You mean the units? They may be right now, for sure. But we're going to see, like in those special cases, we're going to see how we go from certain units, for example, one of mass to one of volume. We'll do more examples. Yeah. So honestly, this is probably the fastest way to do it. There are other ways to do these sorts of things. If you... All right, I'm just going to illustrate this point for our dear friend Nan Lazo here. But let's, if you are confused by it, don't worry. So, we saw 10 to the negative 2 meters equals 1 centimeter. We saw that 10 to the negative 3 meters is 1 millimeter, yes? I don't know where to put them exactly. Let's get back to that in a second here. If we solve both of these for meters, we can do that. And so now, since they're both equal to the same thing, we can say 10 to the squared centimeters equals 10 to the third millimeters, and therefore 1 centimeter equals 10 millimeters. If you just go ahead and cube this guy, you'll get your answer. And then you can just use that as one step unit conversion right there. You can say, okay, I've got my, what did I have, 8.37 cubic centimeters. Here's the new conversion factor I just made. And there we go, 8.37 times 10 to the third. All right, we're done. So that's one way you can do it. You can kind of mess with your conversion factors to kind of shorten it that way. That would work. That's kind of the only way to shorten it at this point. So, yeah. Okay. How do you know where to put them exactly? Okay, that's kind of the main point here, right? You always want to place your units properly so that what you don't want cancels out and what you do want does not cancel out. For example, if we were to put it the other way around, if we were to do this thing, we would end up with some absolutely crazy, unit. Okay, cool. So illustrate what part you mean by where to put them. Do you mean like... Well, try and explain it. I'll illustrate this. You would end up with nonsense if you were to try to do this crazy way. The point of dimensional analysis or unit conversion is it's kind of just a methodical way to mathematically mess with your units. And we're going to see that this is going to be something that is very important because there will be standard conversion factors that we're going to use all the time in chemistry. For example, one that we're going to deal with a lot is something called R, which is going to be the universal gas constant. This is something we'll talk about in chapter 7. We're not going to talk about this now, but for example, this particular conversion factor deals with 4 different units. And by doing so, we're going to see that it's going to be able to interconvert any 3 of these properties into the 4th one. So, for example, if we did not have liters, but we had the other 3 units there, we could use this conversion factor to figure out liters for it. Doing the unit, messing with the units is going to kind of make the need for memorizing formulas pointless. If you can work with the units, you will not need a formula in chemistry. It's a very powerful skill to have here. That's just being methodical. You can totally, if you know how to go from centimeters to millimeters cubed right away, go ahead. I am not going to stop you there. Cool. I just like to do it methodically when teaching this because oftentimes a lot of you have not seen it before. So it's just a way of making it easier for us by showing every kind of step, even though for some people the steps are not necessary. So that's kind of there. I think also you're kind of hinting at using a unit plan, and we'll talk about that in a little bit later today when we deal with complex units. So short answer, we'll get to that part later today. All right, cool. So we'll see this guy again. We'll forget this for now. Okay, but that's an example. Okay, anyways. What were we talking about? Okay, so that was how we deal with cubic units. I think we were also, that was like problem 1 of 2. We were going to do another one here. We were going to convert it to milliliters. Thankfully, this one is much shorter. Something equals milliliters. Our conversion factor, thankfully, we're already given. Notice one of these, we already have our cubic unit within this conversion factor, so we just put it in directly. We don't have to mess with it. No need to cube. And then we get our answer. Hooray, they're the same thing. Awesome. Great, very exciting. Point of doing this, though, is we did not need to cube this. Because we already had our cubic unit in there. All right, let's talk about doing the unit plans here. So when we're dealing with complex units. So for example, let's say I have something that is going through 22.8 meters per second. If I wanted to go to kilometers per hour, we can do this in any number of ways. It just depends on what conversion factors we're given. And so, again, with this, you're totally free to kind of make your own conversion factors, but let's look at what conversion factors we do know that deal with these units. For example, we know that 10 to the third meters is 1 kilometer. That's a conversion factor we know. And honestly, that's all we need for the length part of this. And so we might now be asking ourselves, what are we going to do with that time unit? Well, we've got seconds and we've got hours. Maybe you know a conversion factor between those two, or maybe you know a common conversion factor between those that may be a little bit easier. And yeah, we could say, oh, that's right. We have 60 seconds in 1 minute, and we have 60 minutes in 1 hour. These are just conversion factors we know, right? We already know these things. These are defined things that we're dealing with. And so, the unit plan for this of how we know what to do when, we just look at the conversion factors we have and see how we want to approach them, kind of step by step. So if we have meters per second, we can apply any of these conversion factors we want in whatever order. That's kind of the beauty of it. We can deal with the numerator first, or we can deal with the denominator first. It doesn't matter. We have that kind of that luxury. So maybe in the first step, I want to get rid of that meters part. We can do that. We can say, okay, I'm going to change that now to kilometers. And we're going to keep the second the same. All right, and now, well, you see, if I look on my, unit conversion or conversion factors, okay, we've used the meters to kilometers. All right, so now we're dealing with kilometers per second. Let's look at our conversion factors and see which one of them deals with seconds. And we can see here it's going to be the second one, right? it's going to tell us how to convert from seconds into minutes. And so that would end up, if we use that conversion factor, we end up with those units. We'll have changed from seconds to minutes. And now we see our last conversion factor is going to go from minutes to hours here. And that's in fact the final unit that we're looking for. So it's just a matter of kind of organizing your thoughts, how to kind of do this step by step, and that's how you'll come up with your plan. So we're going to do a number of examples like this, so we'll be able to have plenty of practice with it. Notice every kind of arrow that I've drawn here will correspond with a conversion factor. And it so happens that these are already kind of given in order. So the next one we do, I will not give them to us in order. But those are just going to be the conversion factors we're going to need to get this problem done. And so if you can come up with the plan, the rest of it is just plug and chug. Throw it in your calculator and forget about it. So this is kind of the crucial part here, is coming up with that plan. And that's a skill you'll develop just by doing practice, as well as looking at kind of more and more examples. So let's go ahead and take a look here. So 22.8 meters per second, that's a speed, right? We're able to measure that. That's a measured quantity. So if we look at our plan, it's showing us we're going to need 3 conversion factors. So we know we're going to need 3 kind of fraction lines here. And so we saw that the first one is going from meters to kilometers. We have our conversion factor there. And so we just have to choose which part to put in the numerator, which part to put in the denominator. Since the meters is in the numerator for that first number, we have to put meters in the denominator here so that they will cancel out. Notice that 10 to the third always goes with meters, and 1 always goes with kilometers. That's why I'm putting them together that way. We're going to see that meters will cancel out. We are now dealing with kilometers per second as our units. Our second unit will convert from seconds to minutes. Notice that seconds is in the denominator, so we're going to have to put seconds in the numerator here so that they'll cancel out. Put it in the opposite side. As a result, we're going to have to put our minutes in the denominator. Again, we're going to see that our seconds will cancel out. We're now in kilometers per minute. Notice again, I've kept 60 with seconds, and I've kept 1 with minutes. The last part here is we're going to put our last conversion factor where we're going to put minutes to hours. Notice again, I've arranged it such that minutes will cancel out. And our final units are going to be kilometers divided by hours. And so we're going to see that that is going to be our, that's the unit we're going to end up with. That's what we looked for. So we just have to now throw all this into a calculator. Okay. That's another thing that just takes practice too, right? So just memorizing the prefixes as well. So let's go ahead and plug this in our calculator. 22.8 divided by 1,000 times 60 times 60. Doing that, we get 82. Oh, I'm out of space. We'll be okay. 82.08 kilometers per hour. Now, while we've kind of omitted them for now, we still have Sig Figs to be constantly frightened about. We're going to thankfully see that for most problems, we just look at the Sig Figs of our starting number and poof, we're done. We would just adjust that way. We're going to see that these are what are called exact numbers. And so they do not carry any Sig Fig information. We'll discuss exact numbers in just a second, but taking that in mind, just assuming that they're not going to give us any Sig Figs, if we have 3 Sig Figs in our starting number, notice that all we're doing is multiplying and dividing, which tells us that we need to have 3 Sig Figs in our final number. So we should adjust this accordingly to 82.1 kilometers per hour. And then here we go. That would be our kind of final answer there. So, hooray, we've done it. All right, before I talk about exact numbers, and then we'll do more practice, are there any problems with this particular example? Anything at all that is bizarre with this? The process is going to be exactly the same for all these other problems. If you can come up with your unit plan, you're good to go. It's just a matter of then throwing the numbers in there and calculating it. Alrighty, so in purple, let's write this out. So remember, Sig Figs come from uncertainty in measurement. And so we're going to see that most conversion factors are definitions. For example, 60 seconds is 1 minute. Nobody is measuring, 1 minute compared to 60 seconds somehow and finding them to be different. These are defined. 1 minute is defined as being 60 seconds. Nothing is being measured here. This is a definition. Same thing as a kilometer being 1,000 meters. That is a definition. There is nothing being measured there. As a result, they do not many conversion factors will not affect your Sig Figs because they are definitions. Nobody's going to say, well, there's only 2 Sig Figs in that 60 seconds. Or rather, 1 Sig Fig, I guess, as written. That would just be kind of pointless, right? We're not basing our conversion on any sort of measurement. We're basing it on definitions. Yes, we will. Cassie, definitely. And in fact, I'll write that here. In what color shall we use? How about light blue? Yes. By and large, conversion factors will apply Sig Figs only when crossing from US units to metric units, or vice versa. So, for example, having 1 foot, or rather 3.3 feet is 1 meter, that is not a definition. Nobody has said, okay, we're going to take our foot and base it on the meter. No, unfortunately, because they're 2 different systems, they're based on different things. And so you're going to see that that is a conversion factor where we do have to worry about Sig Figs. And let's think about this a little bit more, because I could also tell you that 3.27 feet is 1 meter. That's true. And we can go further. I don't know what the next digit would be. Feet to meter. Rather, a meter to feet, I guess. If we keep going, I guess it's 3.28. I lied to you. Haha. But, it just depends on how good the measurement system was to figure this kind of equivalence out. Someone had to measure these numbers. Oh my goodness. And as a result, because someone took something that was defined as a meter, they took a meter stick, and they took, a ruler or something, or a couple of rulers, and measured how many feet that were in that meter. And just depending on how expensive their rulers were and how good their vision was, they've come up with different measurements. So these are going to be measured quantities. They're not exact numbers. And so we do have to worry about Sig Figs, though, for when we're dealing with this. So we're going to deal with Sig Figs when we're crossing in between systems. However, if we're staying within the metric system or staying within the US system, we don't have to worry about Sig Figs for our conversion factors. It's only when you start mixing the two that's when things get hairy. You can probably identify it by the fact that there's all these crazy decimals that don't make sense. Generally, exact conversion factors are nice whole numbers. For metric ones, they're often ones that are, powers of 10. We don't have to worry about. The US system, of course, is based on like Rotten Tomatoes or something. So, there are still whole numbers there. For example, if we take 12 inches as 1 foot, or 1 yard is 3 feet, or 5,280 feet is 1 mile, these are all exact numbers. Because they're definitions, because they're all the same system. They're all using the US system. As a result, they're exact numbers. They're definitions. It's only when you start mixing systems that things go crazy. So let's go ahead and see an example so Cassie can see that. Let's say now we take our, 22.8 meters per second. Let's convert that now to miles per hour. Alrighty, let's go ahead and do it this way now. So let's go ahead and I'm going to just give us a bunch of unit conversions, or conversion factors rather. Someone let me know if I'm wrong with the miles and feet thing. I never remember that. Let's see. 60 minutes is 1 hour. And 3.28 feet is, let me make sure we have a decimal in there, 1 meter. Okay. So I've given us all these conversion factors here. Note that the first 3 of these are exact definitions, right? 60 seconds is a minute. Nobody's going to challenge you on that. However, that last one, awesome. That last one is going to be one that is not exact. Whereas the first 3 are exact numbers. So that those first 3, we don't have to worry about our Sig Figs. but the last one we will. Let me just change our number slightly. Let me just throw a 1 in there, just so we can see that the sig figs are going to be problematic here. All right, let's go ahead and look at what kind of plan we might have here. So we're going from miles per hour. I'm sorry, meters per second is what we're starting with, aren't we? Let's go ahead and see what we would want to do here. So again, we can start with either messing with our time unit first, or we can mess with our distance length unit. Of course, you know, look at Eddie here has already done the whole thing, but your sig figs are wrong, Eddie. Using these particular conversion factors, let's see what we can do. I usually just like to start with changing the numerator first. That's my preference. Doesn't matter. You can mess with seconds first. If we look at our conversion factors, we do have one that has meters in it that's going to convert into feet for us. And so by doing that, we can go from feet per second now. If it's these sig figs, that would be the correct rounding of that number, but I haven't done the math yet, so we'll see. So now we're in feet per second. Okay, let's look at our conversion factors again. There is something else we can do with feet. We can convert it into miles. We can do that, leaving our second units alone. Now we've finished the numerator. Now we have to start working on the denominator part. We have to get rid of seconds. Doing that, we can go from miles per minute, and then finally from miles per hour. And so, as you can see, we have 5 arrows. I have to use light blue this time just so we're not all using the same colors. Okay. 4 arrows means 4 conversion factors. Our first conversion factor is going between meters and feet, which tells us that that is our conversion factor between feet and meters. Our second one is between feet and miles. Our third one is between seconds and minutes. And our fourth one is between minutes and hours. So those are the conversion factors we're going to be using here. And so all we have to do is throw those in there in the correct placement, and we'll have figured out the problem. Just so I want to point this out, this is a measured quantity. All of these, though, are oh my gosh, let's see. What color haven't I used yet? This is just going to be this crazy rainbow. These are all conversion factors. I mean, technically the 22.81 could be a conversion factor as well, but for us right now, that's our measured quantity. We're always going to start with our measured quantity, and then we're going to apply our conversion factors to it. So, 22.81 meters per second. I guess I'm going to make that a little bit more vertical. Our first conversion factor between meters and feet. We're going to have to put meters on the bottom, feet on the top. Now we're going feet to miles. 5280 feet, 1 mile. Now we're going from seconds to minutes. 60 seconds, 1 minute. 60 minutes, 1 hour, and then we'll have our answer. Always double check that your units are canceling out. Meters should cancel. Feet will cancel. Seconds will cancel. And minutes will cancel. We're left with miles per hour. That's what we're looking for. So all we have to do is throw in all this crap into our calculators. Right, so 22.81 times 3.28 times 60 times 60 divided by 5280. Doing that. When I do this, I get 51.011454 blah 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 miles per hour. So Eddie, make sure that when you're doing these exercises, make sure you always use the numbers that are given to you. Where in this case, it's going to be okay. With our Sig Figs, the answer will, work out. But just be careful of just throwing it into Google and say, hey, convert this into miles per hour for me. Just because we don't know what conversion factors they're using. So just watch out for that. All right, let's look at Sig Figs. Out of colors. Oh, orange. I haven't used orange yet. So, we have 4 Sig Figs for our starting number. We have 3 Sig Figs here for our second number. And then we have infinity for these last 3 because those are all defined ones. Notice that the 1 doesn't matter here. I hate using this orange, actually. Let's go to dark blue. Anytime you see just 1 in some number in a conversion factor, you don't have to worry about that 1. That's just someone has reduced the fraction from whatever was measured. So, with that in mind, we have 4 Sig Figs, 3 Sig Figs, and then infinity, infinity, infinity for those exact numbers. So we should have 3 Sig Figs for our answer. And so we're going to need to round this to 51.0 miles per hour. Hooray. So yeah, that is how we would do this. So right now it's taking time. That's okay. It's an important skill to have. And so I would definitely recommend doing it methodically like this rather than just plugging it in and say, hey, Google, convert meters per second to miles per hour, or using an app to do it. It's... oh my God. Look, go figure. Google's already telling me what to do. It's hurt me. Isn't that nice? Just be careful there. So that's my advice to you. Knowing the skill is more important than knowing the answer. So there we go. Alrighty. Any questions on that one? Aha. Ah, well then that's just plugging in the answer wrong. Or plugging in since I changed the number on you guys. Yeah. Well, no worries about that. I didn't mean to imply that you had just used Google, but that's often a temptation that students will face. And honestly, on in-person exams, that was the easiest way to catch people cheating. Was just, they would come up with these numbers that would come out of Google instead of using the conversion factor as given. So there's your hint there. It's easy to tell when people are cheating. Cool. Anyways, for non-metric stuff, absolutely. I will never make you memorize, this feet to meters crap. Or even, no, you only need to know your metric stuff. You need to know like meters to kilometers, meters to centimeters, milligrams to micrograms, all that crap. That's what you need to know. Everything else, don't worry. So, everything else will be given for you. So, there we go. Alrighty. Any questions on that one? We have 5 minutes left. Do I want to start? Yeah, let's do it. All right. Density. I'm going to show you here the ability of conversion factors to kind of bypass you having to memorize formulas. You can do as either one. We're going to see that density, which is the letter rho in Greek, not D, unfortunately, is going to be, if you want to think about it in terms of a formula, it's the ratio of the mass of something to its volume. So we're going to see that it's a way of converting between those two quantities. And so, if you do want to memorize the formula, I have a nice way for you to do so. Notice, if we connect these, density is love. It's a heart. Hooray. Mass over volume. It's just a heart. But that aside, we're going to see that density, for example, we take ethanol. Its density is 0.789 grams per milliliter. And so we can use this between mass and volume. Or we can use it as a formula. And we would use then that one. Right. And so that one, thankfully, it's easy to memorize because it's a heart, right? So, by using it like that, if we take a 10-gram sample of ethanol, we can figure out what its volume is going to be. By using it, we can use it either way. If we use it as a conversion factor, it's telling us that we have 0.789 grams for 1 milliliter. I'll throw the unit on there. We would just have to do that. 10 divided by 0.789. And there we have it, let's say 12.7. With our Sig Figs, that would be our answer. This is using it as a conversion factor. That is the first way of doing this. If we want to see it done the other way, if we want to use it as a formula, okay, we know that density is mass over volume. So therefore, volume is mass over density, just solving for V, which is 10 divided by 0.789, which is 12.7. I guess I should have put in our units, grams and then grams per milliliter. Grams will cancel out. You get the same number at the end of the day. So you can do it kind of whichever way you like. It'll work. But this is the kind of whole point of doing this. So instead of having to worry about memorizing formulas, it may be easier for you to just say, oh, hey, look, I can just manipulate the units, cancel out grams, do it in one step, rather than plugging into an equation and then solving it. Either way works. You are totally free to use either way. But this is the power of the unit conversion method, is that you will not have to worry about ever memorizing formulas if you can figure out how to mess with the units instead. And honestly, this skill is going to be super useful in physics if you ever take that. There's tons of equations in physics that can be perhaps better answered through unit conversion. But that's aside. We'll continue this tomorrow. We'll talk about density again, and we'll talk about specific heat capacity. It's another conversion factor we'll deal with. And so we'll do that tomorrow. Your unit conversion worksheet is going to be due this Sunday, so 6 days from now. You can start working on that. I'll go ahead and put a due date on it. You'll be able to completely do it today. There's nothing that we're going to deal with tomorrow that you're going to need that for. So, yeah. All right. See you tomorrow.